Okay, so, alright guys, to the left, you look up the area. Your area in your chart is to the left. Many of you are seeing, like later on in the questions, they're asking a probability of, because this is the probability, the area under your curve. So you look up the left, you're fine. To the left, you just look it up. Make sure you're on the right side. There's a positive side of the chart, there's a negative side of the chart. Be careful also, on the positive side, the numbers start increasing. On the negative side, the numbers on the top are decreasing. One time I did this whole thing backwards. My daughter was taking this in school and my chart is backwards, her chart wasn't. So some charts, you know, are going to be arranged different. When you go to college, they're going to be arranged different ways. Her chart wasn't. So here I am counting backwards. And she came back the next day, she's like, nice going, like my homework was all wrong. I'm like, how is that possible? I didn't realize her chart was the other way. So different charts presented different ways. Our chart happens to, on the negative side, go descending. Now, anytime you want the area to the right, you're going to find your area, subtract it from 1. And this is a good clue. When you look this up, and this area is small, this is a small area, this says this has got to be bigger than 50%. And if it's only 4%, that tells you subtract it from 1. Use your sketches. A lot of you are doing sketches. That's great. That's a big help when you do this. Even when you hit the word problems, sketch it. To the right of this one, we look it up. And now this area to the left is the big one. We only want the small area. We subtract it from 1. Questions on these? Can you use the calculator for this? Anybody use the calculator? Okay. If you're interested in the calculator, again, guys, go to second pairs. Try this if you're interested. You have to come down to the normal CDF. The PDF is just to graph this basically. C for cumulative. Cumulative means it accumulates from the left to the right. So again, this is giving you your area under the curve from the left to the right. On the standard normal curve, your mean is 0, your standard deviation is 1. So for instance, if I'm looking this one up from the left, it needs a lower limit. As a rule of thumb, use negative 999 as your lower limit, 999 as your upper limit. You will never hit those. Just say 999. It's easy to put in that way. You could use negative 9 to positive 9. It would be the same thing. But when we go to do this with S values, we always use negative 999, positive 999. So come down to normal CDF, put your negative 999 in, come to your z-score 1.28, leave your 0 and 1, and paste. And you will get this answer. Now, your calculator's a little bit more exact than your tables are. Well, no, not on these. They're the same because you're going to round to 4 digits. But when we do the in-betweens, your calculator's probably a little bit more exact because we round before we subtract. If you want to go to the right of this, do 1 minus that. Just do 1 minus second answer and pull it down. Okay? It's a nice calculator. The nice one for this, believe it or not, are the in-betweens. The in-between ones are the nicest when we get to this. You just put your 2 values in, your lower limit, your upper limit, 0, 1, and you paste. And it subtracts your areas for you. But then to the left, now remember we talked about this? We said your graph basically stops at negative 3 point what? I forgot what it was. What's your graph go to? 3.49. Negative 3.49, positive 3.49. Down here, look how small it is. It's fairly small. Your end point here is negative 3.49, which means anything to the left of this is virtually 0. Anything to the right of this is virtually 100%. So this is right down on the bottom there. It's got such a small percent. It's less than 1. It's only 0.1% of your curve. That little tail is really, really small. We make them look a little bit bigger because of the way we graph them, but those little tails are really, really small. Here's another one. Here's your 3.49. Even though he's close, it's a very, very small area. Again, it's less than 1%. The betweens work really nice on your calculator. The low level, 0. The upper level, 3.09. Go to calculate. It does both areas for you and subtracts and gives you your final area. If you're going to work them out by hand, you find the areas of both and subtract them. Don't subtract your z-scores, subtract your areas. So if you're going to use your normal CDF for this, your lower limit for this one is 0. Your upper limit, 3.09. Your mean is 0. Standard deviation is 1. And paste. And it will return 0.499. It might even get a little bit more exact. Again, from here to here, you want the in-between. Find the z-score for negative 0.51. Find the z-score for 0, which is half of your curve. And subtract. Always subtract the bigger minus the smaller. Area cannot be negative. Area has to be measured positive. So always subtract the larger minus the smaller. Questions? So we did left, right, middle. Good? The sketches are really helpful. Here's another in between. And look, you're such a big part of your curve. Plus or minus 2 is 95%. Plus or minus 3 is 99.7. Look how close you are. You're almost at plus or minus 3. You should have a large, large chunk of your curve. When they give you an or, we learned in probabilities when we have or, if they're mutually exclusive and they can't happen at the same time, we add on an or. So therefore, to the left, to the right, they can't happen at the same time. We find their areas and we add them. That's your probability rule for an add. Good? You're going to find the area of 1. Don't these areas have to be the same? Aren't they the same because your curve is symmetrical? So isn't it the same on the left as it is the right? So if you looked up the left, you don't even have to look up the right. The right, don't forget, you have to subtract from 1. But because this is a symmetrical curve, if this area is this, then this area has to be the same thing. That's one of the attributes of your curve, that it's symmetrical. Okay, oh, you might not have all of these, huh? Okay, and then the last one. $44? Nope. 47. Okay, now these turned us into probabilities. It's still asking you a probability. So your probability is the same thing as your area under your curve. Your probability says, oh, your area equals 1. So does your curve. Your area equals 1. So if we're looking to the left of 0.5, anything probability less than 0.5, you make your 0.5, you find your probability. Find your curve, area to the left. If it's area to the right, then you do the 1 minus.
Where can you find 0.615? 0.69 was about 0.59.
You look up the z-score.
But is it 0.50?
Yes. Yes. You would look up in your left-hand side, 0.5, and in your right side, 0, 0. You're right at the first part of it. And you get your 6915. Your probability is your area under your curve. Okay, to the right, again, you're going to subtract it from 1. The 1645 is one of those z-scores that falls exactly in the middle of 164 and 165. If you looked up 164, you get one answer. If you looked up 165, you get a different. What they wanted us to do here is what we call extrapolate. Find exactly the halfway point. If you notice, this is 5 under, this is 5 over. So exactly halfway is smack in between. If you did that, it's called extrapolation. You didn't have to do it. You could either round to either one as long as you subtracted it from 1. As we go through this and we use these in formulas, that's one of the ones that they give you. Usually they'll give you the z-score 1.28, 1.96. This one they always use 1.645 because it is exactly in between those two areas. And you didn't have to do 51. Oh, 51 you did. Okay. Here's an in-between, the probability of occurring in between those two z-scores. Probability is the area under your curve. 57. Here again is your probabilities. And this time they wrote it as a probability statement. What is the probability? Probability is area under your curve between 0.89 and 0. Draw these curves out. It makes such a difference. Okay, and 61. 61 again is your or. I want the area to this side or the area to this side. Again, this is symmetric. They're the same size, both ones. So if you looked up one of them, and you looked up this one, subtracted it from 1, it would still be this. They're symmetric. So kind of like doing these, you get to see a lot of your attributes of your curve. I guess I was hoping that you saw a lot of it. 10. Questions? No? We're all good? Okay. So if you kindly clear your desk, you have a little quiz. No.